Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In continuation of our linear algebra series, in this video we will learn about equation of a circle and equation of a sphere and hypersphere and the properties of it. So without any delay, let's get started. So let's understand equation of a circle. So let's say I have axis like this. So I have x and I have y. And I have a circle like this. So this is my circle, right? And this is my origin 0 comma 0, and the radius of this circle is called r, and radius is going to be same at every point on the given circle. Is that clear? So this is how you will define a circle in a 2D plane. And what is the equation of a circle? It is x square plus y square equal to r square. So this is the equation of a circle in a 2D plane, given that center is 0 comma 0. So what if my center is at point some h comma k? It is not always mandatory that you will have the center as origin, right? So in this scenario, my equation of circle would be x minus h whole square plus y minus k whole square equal to r square. So this would be my equation of circle if my center of the circle is at h comma k. Hopefully that is clear. And it is a 2D, that is why we call it as circle. And if it is 3D, we call it as sphere. We will also understand all of that in detail. And we have seen this is r, right? So let's say I have a random point. Let's assume p dash here, and I will call it as x1 comma y1. And what is the distance of this point to this origin? So that would be, distance would be root of x1 square plus y1 square. Clear? So this is the distance. And if I want to calculate or observe if this distance d is inside the circle or not, that means this distance d should be less than my r value. Clear? So if my distance d is less than r, that means my point is in the circle. Clear? And let me rephrase this here. So this is my equation. So this would be x1 square plus y1 square less than r square. So if this is the condition that it satisfies for a given point x1 and y1, that means the given point lies inside circle. X1 square plus y1 square is equal to r square. So what is this condition? That means the distance is equal to r. That means the point lies onto the circle. So this is like point lies on the circle. And if my x1 square plus y1 square greater than r square, then point lies outside of circle. And why are we calculating all of these things? That is also we need to understand, right? We need to understand the intuition. In the previous example, we have always seen that we will always draw a straight line to separate the points, right? So this is how you will separate, and we will calculate whether a new given point p, whether it is on one side or the other side of the line. So what if in a real time scenario your curve is something like this? So here you are not calculating a line, but here you are having a curve that separates two set of points. Let's assume I have this set of points here, which is of class 1, and I have another set of points outside this circle. So like this. So this is a curve that separates both of these things. So at any given point, let's say some p, I have to calculate whether this point is outside of the circle or inside of the circle. And by calculating this outside or inside, I will classify it either as blue point or magenta point, right? So that is why we need to understand or learn all of these concepts. And then if we want to increase this to 3 dimensions, we call it as sphere. If you look at this one, we have 3 axes, x, y, and z, and I will have a circle like this centered at origin 0 comma 0 comma 0. So my equation would be, let's say I have x1, x2, and x3, all of my axes, and my center is at 0 comma 0 comma 0. The equation of my circle would be x1 square plus x2 square plus x3 square is equal to r square. So if I have to generalize for n dimensions, this would be sigma xi square I equal to 1 to n is equal to r square. So this is my equation of a sphere in case of 3D, and in case of ND we call it as hypersphere. So this is of n dimensions. So these are all the things that we need to learn. If you want to generalize whether a given point lies inside or outside, how you will calculate? You will calculate if sigma I equal to 1 to n, xi square less than r square lies inside, and then if it is greater than r square lies outside, and if it is equal to r square lies on the circle or sphere. And this is how you will learn all of these things. And then one last thing is, if my center is at h comma k comma I, let's assume like this, and then my equation of a sphere in 3D would be x1 minus h whole square plus y x2 minus k whole square plus x3 minus I whole square is equal to r square. So whatever the generalizations that we have done, those are all for the circles or spheres or hyperspheres in which the center is at origin. If you have any queries so far, please let me know in the comment section below, and I will reply to each and every one of you.